Hello. Hi everyone. Today we'll continue looking at the Red Hat Certified Engineer Exam question bank. Next, let's move on to question 13. Question 13 mainly focuses on generating hardware information, and the requirement here is for us to, for all of our nodes, generate the corresponding hardware reports, which means we need to output the hardware status for each of them. So what does this mainly include? First, the main inventory's host name and memory size. BIOS version disk device sizes. Here, the disk devices mainly include two, VDA and VDB. And also, each line in the output file should have a key value pair for better clarity and easier organization. Naturally, as for this particular file, we can simply obtain it from the usual, commonly used location. As we have done many times before in similar situations, we can copy it from our usual place, the classroom, or rather, we should say download it. After downloading, we can then use it as a template for making modifications. Now let's take a closer look at this part. The method for generating a hardware report. For this question, the main thing to pay attention to is that we need to generate a report for each host. Here, we use all the hosts. A report needs to be generated for every host. Also, for each line, the final requirement for the result is as follows. In other words, please ensure these criteria are met. Each line should be a key value pair. For example, hostname equals something, memory equals something, BIOS equals something, disk size equals something, and so on. It should follow this format, and the format must not be wrong. You can't just write the information however you want, or simply put all the information into a file and call it done. That's not acceptable. What is required? It must be a complete one-to-one format, meaning each key is paired with a value in the form of key value pairs. This is the requirement for our result. After we finish running the playbook, we want to see such a file in every node. That's the main goal of this task. Next, let's take a closer look at how to solve this problem. First of all, we need to start by using this. Curl command to download a sample file, or rather a template file. We need to use this template file to make some adjustments to our content. So first we need to enter our virtual machine and then download the file. Alright, next let's open the terminal and start the operation. So first, the first step is to download the current content. When it comes to downloading here, basically, we first use the curl command to download some content from our usual place, which is the content inside the classroom folder under the class directory. After downloading, you'll see that the file is named like this. It's called hardware report empty. Okay, that's one of its contents. As you can see here, these are the requirements. This is the final requirement. First, host equals, well, that's our host name. Memory is followed by the memory size, and BIOS here refers to the BIOS version. Then the next two lines are for our two disks. Note that it's the sizes of two disks. Make sure to include both disks. Don't just write one disk, because if you only include one, it won't be complete. So this is the format of our file. Of course, this is just an example. So what this means is that the final result should look like this. It doesn't mean we are supposed to modify this file directly. Now, let's officially start editing our hardware report. First of all, what does the hardware report mainly involve? The first thing to note is that all nodes need to participate together. So here, let's start by editing the file. According to the requirements in the prompt, which file are we supposed to edit? Yes, it's this file. We're currently in the enterprise directory, so it's very convenient to work with the file. Alright, after opening up this file, let's go ahead and start writing. Now, first of all, there are actually three important things that we really need to pay very close attention to. Groups, right? Whether it's 3 groups, 4 groups, or the host within those 4 groups. In total, there are 5 hosts, and all of them need to participate together. So actually, we don't need to specify any particular group here. We can just write all directly. But first, of course, we need to declare the name. For example, let's write a hardware one. Report, hardware report. Then next we start writing. First we list all the hosts. Next comes the specific tasks. Alright, now everyone should pay attention here. For the specific tasks, what do we need to do? We need to break them down into several points and proceed step by step. What does that mean? Let me explain. In our topic, the requirements just now were actually these points, right? 1, 2, 3, 4, 5. A total of 5 requirements. So here, we actually need to break them down into 5 different sections, which means 5 separate tasks. So here, we execute them one by one. Just carry out one line at a time, and in the end, we can piece them together. Just combine them at the end. So first, let's take a look at the first one. This part here. The final one. As for the content, it's actually divided into 5 lines. Here, we can just use 1, 2, 3, 4, 5 as the names for the 5 tasks. That's enough. Just name the 5 tasks accordingly. But before we write out the 5 tasks, what do we need to do first? We need to first move this file. Where should we put it? We need to place it on each node, because in the end, we want to write this information into the file on every node. The ultimate goal is for each node to have this file. Yes, every node has this file. It's not that we just write everything into a single file. It's not like that. Each node has its own file, and each file contains that node's own information. That's what the problem requires. So, before we write these 5 lines of content, what do we need to do first? We need to make sure that this file exists on all 5 nodes. So how do we make sure of that? Well, what do we need to do here? Well, through our download command, we can say, yes, put ours. The file we just saw is available for download. How do we download it? Well, we do it like this. Basically, we haven't used this before. We haven't used this module at all. It's a module that helps us download content. So first, let's download the hardware report. Alright, where did we download it to? We downloaded it here. Now, we need to use our download module. The download module works like this. It's just downloading a URL. That's what it means. Okay, so when we start writing the download part here, what's the format? As it says here, it's download URL. So basically, the URL is the source path, which is our link. The source path is this link, and we use it to download from this link. To where? To the local machine of each host specifically. Let's finish writing the file first, okay? Alright, this is the file name. Where do we put this file? We place it on all of our hosts. Just put it in the directory. It requires that it be placed in this directory, in our root directory. Alright, after finishing this step, this is our first step. We need to make sure that this file exists on every node. This way, whether we need to add or modify something later, it will be much more convenient. To be precise, it's actually about modifying, not adding. Please note that. What we're doing here is not adding, but modifying, because at this step, we've already placed that file on all the nodes. Yes, so this file has already been placed there. And inside this file, it's really just a format, right? It doesn't contain any actual information yet. Ultimately, what we need to do is, since these are key value pairs, with the key in front and the value after, we need to replace all the values with the correct results, while leaving the keys unchanged. The keys stay the same, and we update all the values. That's the effect we're aiming for. Next, let's take a closer look at how to modify these 5 items. Now that we have the file, we'll focus on updating the 5 items inside it. Alright, so first, let's start by working on this content. Okay, let's scroll down. Alright, at this point, we'll start working on the remaining 5 tasks. Now, this counts as 1 task, but actually, for this problem, we have a total of 6 tasks, so this is quite a long question. So, overall, this is one of the longer questions in our entire exam, so everyone should pay attention here. Also, this question involves some symbols, and later on, we'll be using some variables and such, so the content will be a bit more complex. There will be quite a lot of content, so everyone needs to be extra careful with this question. Really pay attention. The good thing is, even though there are still 5 tasks left, the format of these 5 tasks is basically the same, so once you get used to writing them, the overall format shouldn't pose much of a problem, and there won't be any major differences. Alright, next, let's officially start writing the remaining 5 modification methods. Let's write the remaining 5 modification methods, starting with the first one. Hostname, right? The first one is the hostname, so let's start with the configuration for the hostname. As for the main interface here, we'll just use name to report, right? We'll just report it. Report 1, and then we'll have reports 1, 2, 3, 4, 5. Okay, next up is for the modification here, the module we use, actually we only need one module. By using our line in file, we can modify our files. The line in file module allows us to modify our files. So here it is. The main function of this module is to ensure that when a specific line exists in our file, it can. First of all, you need to specify the path to the target file. Then, using our regular expression, it matches the corresponding content and then performs an operation. It can modify and replace, perform modifications and replacements. This is one of the uses of our line in file. First, let's look at an example. Once you see an example, you'll understand. So first, let's write the name of this module. What's the name? Line file. Alright, that's the name of our module. It is indeed quite long. This block is really long, isn't it? So after writing that, what's next? As I mentioned earlier, how do we perform a replacement? First of all, you need to let our module know which file you want to modify, specifically where the file path is. So here the first thing is to specify the file path. The format below is the same. We follow 3 steps. The first step is to determine the file path. That is, where the target file is located. Once this is confirmed, just like above, isn't it? This is the path to our target live streaming room, the one we just copied over. If we want to make changes, we'll be modifying this file. So, just now, what we did with getURL was essentially downloading the file from this link to our local machine, to the local environment of all our hosts. Next, what can we do? Well, we can use the modify module to make changes, modify the contents of the file. Now, pay attention here because we have 5 of them. There's something you need to note. We have 5 hosts, not just 1. Their formats, well, maybe not the format, but the information, specifically the hardware information, will definitely be different. Right? They're definitely not the same. Or at least not exactly the same. So here, we definitely can't modify them all at once, right? We can't edit them together because if you do, what kind of problem might occur? Well, right, maybe 1 or 2 will be correct, but the others might be wrong. So when we make changes here, we definitely can't just write things directly. For example, if we want to specify the host name, our host names are all node 1, node 2, and so on. Can you just write node 1 to node 2? We have 5 hosts after all. So which one are you supposed to write, right? That's the problem. Yeah, that's the issue. So here, what do we actually need to ensure? We need to make sure that every modification matches up correctly, and to do that, we absolutely have to use variables. When it comes to using our variables, we've already used the hostname variable many times before, right? So let's take a look at this part. How do we write it? First of all, the path. There's nothing special about the path. Just copy the path from above directly. Alright, once the path is set, the next step is the regular expression. We use a regular expression to match the line you want to replace. Since we have 5 lines, each of the 5 tasks matches 1 line. Be very careful not to make a mistake here. If you do, you might end up with, for example, the second and third lines swapped, which means the values are also swapped, and that would be incorrect. So here, you must make sure that each line matches up correctly. For the first line, it's our host name. The first line is the host name, so why do we use a regular expression? It's to. After matching the line with the host name, we then perform the replacement. So how do we match it? We do it by what exactly are we matching? We're matching lines that start with a certain pattern. If we look back at the file above and compare the differences, actually each line is different, so it's actually quite easy to distinguish them. When it comes to matching here, we definitely can't match from the end because the end contains our values. So what we need to match is the content at the beginning, the 5 keys. Host, memory, BIOS, disk size, VDA, VDB. These 5 are all different from each other. None of them are the same. So when we're matching here, we can use what the line starts with to match. For example, the first line is the host name, right? We can match lines that start with host. Once we find such a line, we replace it with the host name. That's how it works. Similarly, when we match memory, we replace that line with the memory information. That's all there is to it. Next, let's take a look at the specific matching method. As for the matching method, here we use... what's the more traditional way to start? What should I use? Well, use this one. The ellipsis, actually, we use the ellipsis. And here we use host, meaning lines that start with host. For example, then we replace it with the host name. How do we perform the replacement? Here we use line. This option is used for replacement. When we replace, we are replacing the entire line. Why is that? Because this is a full line replacement. Please pay attention, everyone. We are replacing the whole line. So when replacing the entire line, we must write out the complete content of that line. We can't leave out any part. In other words, we can't just replace the value at the end and ignore the key at the beginning. That won't work. So here, first we write the key, which remains unchanged. The key doesn't change, the prefix stays the same. Then next, since we need to fill in the value, we look for A. We just need to fill in the topic name at the end. So what is the topic name? Actually, it's already told you above. This is the main host name. So how do you write the host name? You write it like this, because we need to use a variable here, since each host has a different host name. You can't just write it as node 1234. So here we can only use a variable, and that variable is in fact, we've used it before, right? The inventory host name, each node's host name, as you probably remember. So the way to write it here is, first we write the variable in parentheses, leave a space, then write inventory. And what else do we add? We add host name. Hey, pay attention. There's a slash here. There's a slash, but in the original text, there isn't one. So here, compared to the original, we basically add a slash. That's the answer. Also, be mindful of the parentheses and spaces on both sides. Once that's all set, this is the first one. All right, the first one is done, right? Yeah, that's it for the first one. This is a configuration for our topic name. Next, let's look at the second one. The second one is memory, right? The second line is memory. By analogy, the next four should all be pretty similar, right? You should be able to write them yourselves. So what can you do now? You can try writing it yourself first without looking at the answer. After you finish, compare it with the answer. Are there any differences? If it's the same, congratulations. You've already mastered this question. If not, just make a note of the variable names. The main thing to pay attention to in this question is the names of these 5 variables. Everything else is very straightforward, right? The paths are all the same. These 5 paths are identical, right? What are you matching? You're matching the ones that start with these 4 or 5. For post, you just need to write out these 5. That's all. There's really nothing difficult about these 2. The main thing to remember is the variable names on the line here. You don't even need to memorize the first one, right? For the first one, you just add a dash to what's in the question. Now, as for the next 4, you need to remember them a little bit. They're pretty similar to what's in the answer, but not as obvious as this one. There are some slight changes. So make sure not to just copy what's in the answer and turn it directly into a variable. That won't work. There are some small differences, so you need to adjust it to the variable names. So we finished writing the first one, right? Now let's move on to the second one, which is about memory, right? Okay, we won't go over the previous content again. As for the names, we'll just use them directly. Like report 112345, for example. Move a little to the side, okay? And then for the second one, as for the module, we'll keep it the same for all of them. The next 5 will all use this same module. It's just a replacement, right? We're just replacing this content. Or maybe it's better to call it overwriting the content. So we shouldn't say replace, right? But overwrite. We're not really replacing anything. Overall, we're overwriting the entire line of content. It looks like the front part hasn't changed because, well, the content at the beginning stays the same. So it seems like we're just replacing the latter part. But actually, we're overwriting the entire line with this one. So it's like we're using this line to overwrite the whole thing. And since the front part doesn't change, it just looks like we're only replacing the end. But in fact, it's an overwrite. So here, it's actually an overwrite. All right, well, so now, next, let's take a look at this. For the second one, our path here doesn't change. So we can just write the path like this. Don't make a mistake here. If you're worried about making a mistake when writing it, or if you're afraid of typos, just copy it, right? As for this part, actually, both of these lines can be copied directly. That is, this line and the path line, because these 2 lines are exactly the same, right? We're using the same module, and the path is also the same. It's just the matching method below and the final replacement content that are a bit different. That's all. These 2 lines can be copied. Next comes the matching part, right? So how do we match it? All right, let's look at the example above. When does it start with YI? So what does it mean for memory to start with something? That is, it starts with the word memory. Pay attention to what it starts with, plus memory. Take a look here. Actually, it's fine since everything is in uppercase, so there's nothing special to watch out for. Usually it's all uppercase here, so there shouldn't be any issues. The values that come after are in lowercase, but as for the keys in front, we always use uppercase. For variables, we switch to lowercase. Please pay attention to this. Don't mix up uppercase and lowercase, don't reverse them, and don't just capitalize the first letter. In general, the entire key should be in uppercase. And the values that follow are all in lowercase. Please pay attention to this. If you get the case wrong, it won't work either, because in our Linux system, case sensitivity is strictly enforced. Uppercase is uppercase and lowercase is lowercase. They have different meanings. For many commands, using the wrong case can lead to different results. So here, case sensitivity is very important. If you get the case wrong, it will be considered an error. You must strictly follow the requirements stated in the question. There can't be any mistakes at all, whether it's case sensitivity or punctuation. You can't get anything wrong, not even a little bit. Next, let's take a look at this. For memory, it's memory, all uppercase. Just so you know, please remember that. It's important. Good memory. After writing memory, next we'll move on to replacing memory. For replacing memory first, the options remain the same. So how do we handle these 5 tasks? They look long, but actually they're quite repetitive and not really difficult. Right? Because most of the content stays the same. Only a small part changes, just some key information. The key information is actually given in the question. Just change these few things and the rest of the content doesn't need to be altered. Relatively speaking, this question is still quite... Admittedly, it is long. It really is long. It just takes a bit more time. When you're starting out, you'll need to spend a bit more time on it. But in reality, this question isn't actually that difficult, right? You really only need to remember 2 of the tasks. Even though there are 6 tasks in total, if you remember 2, that's basically enough. Now, let's take a look at the memory, specifically this variable. First, of course, let's fill in the previous keys. So after filling in the keys, what do we get? We get a variable. Now, what exactly is this variable? It's our memory. Previously, we didn't have this. This is our total memory, the total memory. Because what does the question require? It says that for us, for B, here it works like this, we will use MB as the unit to display the size of our host. Total memory. So total memory means memory total plus our unit, as we've discussed earlier on. Since it needs to be an MB, we simply add the unit at the end of the value. It might look a bit odd at first glance, but actually, it's just a few words put together. A few words combined to form the final result, really, right? That's how Ansible shows the total memory unit, as you can see. Now let's take a look at this. After writing this part, actually, this is the second one. For the second one, it's the same. After finishing, check the parentheses, spaces, and so on. If everything's fine, then we move on to the third one. So, what's the third one about? The third one is about our BIOS version. Actually, how should I put this? Generally, this kind of hardware information isn't actually that important in practice, but since we're being asked to collect it here, we should go ahead and do it. As for the BIOS version, overall, its impact, right, on the environment isn't really that significant. No matter what version you have, as long as your system can boot up and run properly, then it's a good BIOS. So here, what we need to do first is switch to the third one. Let's begin the third task. We'll briefly go over the third report. The third report starts now. The previous content remains unchanged. Next is the path. No changes here. As for matching, this part will be different, so don't just copy it as before. Alright, everyone pause for a moment. Let's take a look at what that is. This part is fixed. It always starts with something specific, so we don't need to change it. Let's go back and see what it's called. It's very simple, right? It's just called BIOS. Alright. Here, let's try to match it together step by step, just like this. There's actually one more important thing to pay attention to here. Starting from the third one, there's a detail you need to be aware of. That is, in BIOS, there are 2 uppercase letters. Yeah, it has 2 uppercase letters, right? Actually, it's fine. The way we're matching is by checking what it starts with, so it doesn't really have much of an impact. But if you just write BIOS directly without the starting symbol, then there will actually be a problem with this question. The third one will have a problem. Why? Because as you can see, there are 2 uppercase BIOS. Yeah, so this is something you need to pay attention to. Of course, in the actual exam, this question usually doesn't change much. Generally, there won't be much variation in this name. But you still need to pay attention. When you encounter similar content later on, be careful as well. If you want to match certain content, and if this situation appears twice in the same line, you need to be aware of it. So, try to make the first occurrence a bit more unique. What does that mean? For example, you can do something like this. I actually didn't add it earlier because it wasn't really necessary before, right? For instance, right here, you can add an equal sign. In some places, there's no difference because one starts with how and the other with deng. Both start with so they're actually the same. In this line, there's only this one piece of content. But as we just saw after this BIOS down here, you need to give it a reminder. In this line, we have two uppercase standards. So it's best, right? You add an equal sign, that way you can distinguish them. If you don't add the equal sign, actually, you can still tell them apart because we have this one in front. The symbol that starts with when can actually help you match the content as well. But if you just write quotation marks and put BIOS inside, that's wrong. Why? Because there are two BIOS entries. If you only write one BIOS, it will match both at the same time, which isn't acceptable. The others don't really matter. They're all uppercase, just uppercase at the beginning and lowercase at the end. But in this case, both are uppercase. This can cause some problems here, so everyone, please pay attention to this. Right? If you include an equal sign, then there's absolutely no problem. Even if you forget the angle bracket symbol in front, it doesn't matter. As long as you have the equal sign, it will still help you, right? It will still match the BIOS for you. This is something you need to pay attention to. You might notice, hey, when you first look at the question bank, why is there an equal sign here? Well, it's mainly to address this issue. Of course, actually, it's fine if you don't add it here. It still works without it. But if you do add it, it's just a bit safer. Just to prevent what? To prevent issues from cropping up later. If, for example, there are some changes in the format or content of the file, then it's easy to make mistakes, right? It's easy to run into problems when filtering. What's the most important thing about this matching? You must be able to match a unique value. That's the most reliable way. When you're modifying some file content, you have to match a unique value for it to be the most stable. Now, with something like the BIOS, if you try to match the BIOS directly, you can't match a unique value. You'll end up matching two pieces of content. So in that case, how do you make changes? So in this case, whether we add this angle bracket symbol in the front or an equal sign at the end, our purpose is actually just one thing. Yes, there's only one purpose. What is it? It's all about getting that unique value. I just want that unique value. Absolutely unique. That way, when we make changes, we can ensure that it's always a one-to-one modification. Don't let it become a two-to-one change, or else problems will arise. Alright, so why do we add the equal sign here? Actually, you don't have to add it, you can leave it out. But adding it makes things more precise. Okay, next let's look at line. When we make changes here, let's see, this is the BIOS. As for this BIOS variable, it's pretty straightforward. It's quite simple. There's nothing particularly special about anthiable. As for the memory variable above, just take a look yourself to understand what it means. It looks a bit odd because its requirements are unusual, which makes it appear strange. But the BIOS variable below is very normal, right? It's just the BIOS version. Okay, this is our first. 3. Be sure to check for spaces and parentheses before and after. Every time you finish one, check it. Just give it a quick glance. There's no need to look at it too closely. Just a rough look is enough. Also, just make sure the indentation is more or less aligned. If you really stare at it and scrutinize every detail, it's not necessary. Really not necessary. Because when we run it later, it will automatically help us check. If it's correct, it'll go through. And if not, it will tell you exactly which word has an issue or where the formatting is wrong, right? Previously, we often encountered some minor errors when running it, and it's actually a good thing when you run into them. It means, well, when you were writing this part, there was a bit of this kind of issue. It's just a bit careless, right? Or maybe you typed too fast and made a mistake. So if you can really get familiar with typing this part, and even encounter more errors, it will actually be very helpful for your future exams. So don't just, Here, you should really try to make yourself faster. The faster, the better. Type as quickly as you can. Making mistakes is no problem. It's fine to make mistakes, right? If you type fast, it's normal to get errors since it's easy to make mistakes when you're going quickly. Just try to type quickly, and then after you get an error, debug and fix it. If you type slowly, it's actually not that easy to make mistakes. That's true. If you watch each line carefully and type line by line, it's really not that easy to mess up. But you have to remember, during the exam, we're on a time limit. If, for example, I had a whole day to type slowly, I'd definitely get it done, right? No matter what, you'd finish it. But in reality, during the exam, you actually have less than 4 hours. I mean, the intermediate level exam, for the beginner level, it might be less than 3 hours. For the intermediate exam, you have 4 hours. Remove your inspection time, right? So, excluding the time you need for checking, actually, you also have to set aside some time in case you run into some serious errors that take a long time to troubleshoot. In situations like this, you really need to set aside some extra time. That's why I always tell everyone to try their best to Type a bit faster, type a bit faster. Try to practice and get more proficient, so you can, ideally, finish the beginner level in half an hour and the intermediate level in an hour. What's the benefit of this? If something goes wrong, you'll be able to handle it more easily, right? If you have 3 hours in the morning and you finish in half an hour and there are no errors, you can just check your work and leave. After you leave, you can have a meal, then take a look at the questions for the afternoon and review the afternoon's exam. If you make a mistake, well, even if you're unlucky and make a mistake, it's fine. No worries. If you finish in half an hour, you still have 2.5 hours left to keep working on it. The brand name is fine, right? How come there is no mistake in the two halves? Right, it's the same in the afternoon. You have 4 hours. You finish in just 1 hour. Right? So with the remaining hours, if you encounter an error, you have time to troubleshoot it. If there are no errors, it's the same. If there are no errors, of course, that's ideal. But the main concern is making mistakes. It's not a problem if you run into errors during the exam. Especially in some exams, there might be changes in parameters that you didn't notice, and you still follow what's in the question bank. It's okay, right? If you get the parameters wrong, you'll definitely lose some points, but it won't be fatal. However, if you do encounter some errors, if you run into errors actually when you're troubleshooting, also, everyone shouldn't just copy or memorize the question bank answers word for word. Once you've practiced enough, it's like just memorizing the answers for the exam, right? But really, try not to do that. You need to understand the meaning behind each question, understand what each question is asking. After you understand it, then you can quickly type it out. The benefit of understanding the meaning is what? When you encounter an error, right? You can see which part of the problem it is, right? You can go and fix it. If you just memorize things mechanically, what could happen is, if, let's say, you don't run into any problems the whole time and you're very skilled, well, that's just good luck. Alright, then you pass. But if, say, you accidentally type too fast and make a mistake somewhere in the middle, and after making a mistake, you get an error, but you just can't figure out what's wrong, and you can't fix the error, right? That's not going to work, right? So even if you type really fast, it doesn't help if you can't catch your mistakes. So here's the thing. First of all, everyone must really understand the meaning of each question, the meaning of every task, right? After you understand them, then you should execute and solve them as quickly as possible. This is one of ours. This is the main content. This is our main focus. Alright, so here, let's first continue with our fourth point. Let me briefly explain it to everyone again because we're almost done with this topic, right? Since we're about to finish discussing these common types of questions, I'll also take this opportunity to mention some important points to watch out for, as well as some issues that often come up during practice. This also includes some issues that may arise during the exam. So first, let's get back to the fourth point, right? We're on the fourth one now. Let's get back on track and continue writing. This one also involves the disk, right? For the disk here, it's report 4. Here, let's take a look. For the disk, this variable is actually centered around the name of the disk. It's based on the disk's name. The previous content remains unchanged. The main thing we need to pay attention to is what the variable is. As for the disk names, the question actually gives us 2 disks here. Yes, actually, there are 2 disks. What are they? One is A and the other is B, which means VDA and VDB, the first and second disks, respectively. Now, when matching here, everyone needs to pay attention. Don't write too little. When matching here, you definitely need to write a bit more. The reason the previous 3 were written with so little is because they're very unique. This is exactly the issue I mentioned earlier about filtering during matching. You have to ensure uniqueness. The best matches are those with distinctive characteristics, but in this case, the 2 are very similar. So here, we need to write a bit more. If you stop at specifying the disk size, is that enough? No, because there are 2 disks and both have the same size. You have to specify the exact disk name before you can stop. Because the one below is called disk size VDB. In fact, the only difference between them is a single letter, so here we really need to write a bit more, just to be sure. Alright, once we've matched it, next we'll start replacing. For the replacement, first just copy the previous part again. Disk size VDA. Okay, and what does this equal? Since the front part is long, naturally the back part will also be a bit longer. Here, this is our device. Please add our name. Add the size. Okay, here are the parts. The order here is a bit different from the previous one, right? The sequence of the content is not quite the same as before, so pay attention to that. Just make sure you don't write it backwards. As long as you don't write it as size.vda, you're fine. If you write it as size.vda, then that's it. So what about the next part here? Let's start writing. Report. 5. Second line in file. For this one, first of all, let's not rush the previous part, because why do we need to pause here? Well, there's a bit of an issue here because this is the second disk, right? This is the second disk, and as you might have noticed, there's actually a minor problem here. So then, what exactly is it? It might not exist. It might not have a second, but the first disk is definitely there. As a virtual machine, if you don't have a disk, you can't even boot up, right? You must have at least one disk. So VDA is always present, but VDB is already the second disk. The second disk might not be there, it might be missing. So what's the issue here? You can't guarantee that every node will have this second disk. So our approach here needs to be a bit different. First, the matching part remains unchanged. We'll still use the same method to match. Just find the ones that, well, start with V. As long as it starts with DB, that's fine. Nothing changes here. You can write this together with the previous part. Alright, there's no problem here. But when it comes to replacement, things are a bit different. There are actually two scenarios here when replacing. What are these scenarios? Let's start with the first one. So, the part at the beginning. The key itself doesn't change. No matter what, the key stays the same. You can't just go and change the key. So the key doesn't change, but what does change? What changes is actually... it's the variable at the end. So what exactly can change about that variable? First of all, everyone should pay attention to this. The equal sign isn't written here, right? Normally, let's say, let's divide it into two scenarios. In the first scenario, if this VDB exists, meaning it's present, how should we write it? Actually, the way to write it is the same as above. V, the size of the DB. This time, make sure you don't just copy it blindly and write it wrong. If you write two VDAs, then that's it. Then you'll lose points again. So here, we've finished writing the first scenario. This is the case where we assume it exists. That is, the host has this VDB disk. That's the first scenario. For the second scenario, if it doesn't exist, what do we use here? We use OR. Or it's a pipeline service. Well, Guangde Grape actually has different meanings in different places. Here, it doesn't refer to the traditional meaning of a pipeline diagram. If you interpret it as a traditional pipeline diagram here, it would definitely be wrong, right? Because here it actually means OR. It's used in the sense of OR. That is, if the first one doesn't exist, then by default, it will use the one after it. If the first one exists, it will use the first one. This is what OR means here. This pipeline symbol does not mean OR. Alright, here we'll simply set the default value to... now there's nothing, right? And after that, that's our content. Also, pay attention to the parentheses here. Be careful with the parentheses. Alright, so what does this mean here? If it exists, then it returns the size of the VDB. If it doesn't exist, then it uses none as the default value. Using the default value, what this means is that even if the variable is undefined, it will use the default value. This is really necessary. Why? Because if you don't have this disk, you definitely won't have this variable. Right? You can't just say, hey, right now, I've already written VDC, VDD, VDE in advance. Are these variables necessary? No, they're not. You know, the variable for this disk only exists if the disk itself exists. If the disk isn't there, then this variable can't possibly exist. So here, actually, this check, or you could call it a pipeline operation, or just a check, or you could call it whatever you like. The if statement check can also work, because with an if statement, it's, right? As long as one of the two conditions is met, that's enough. It's the same here with the previous part. In the previous part, oh, I just noticed a typo in the previous part. It's a specific value, meaning that when our VDP exists, it will be generated. If the VDP doesn't exist, then this variable simply doesn't exist at all. So the true on the right side actually means that when the left side doesn't exist, when the variable is undefined, at that point we use the default value. We just use the default value. So that's one of our tasks. These are the 5 tasks. To be precise, this problem actually has 6 tasks. So this is part of our 6 tasks. After you finish writing this part, make sure to check it carefully. Just double check after you're done, because there really is quite a lot of content here. It's not very difficult. The content isn't hard, but there is quite a bit, so we need to check it carefully. Now let's save it. Actually, let's skip the checking and just run it directly. We'll execute it right away. There's not much point in checking, right? With so many files, it's not really necessary to go through them line by line. We have more advanced methods. We can simply run our script to help us check. By running it, we can check everything. All the modules used in this script are actually just one module. They're all the same module. They all count as one big module, and we've already installed them earlier. So, regarding the modules, this question definitely shouldn't throw any errors. If you do encounter a module-related error, as long as you've spelled the name correctly, it must mean that the module hasn't been installed properly yet. Most likely it's because with some of the previous questions, maybe we didn't do them correctly, or we didn't complete the installation, maybe we didn't get everything fully installed. That's definitely possible, but we've already installed the modules needed for this question before, so there shouldn't be any errors related to the modules for this one, and there are no formatting errors either. Even though this file is quite long this time, we have a pattern to follow, so we'll tackle it step by step according to that pattern. As you can see, everything is highlighted in yellow. Everything is correct, not a single mistake. This is basically the longest file we've ever written, and yet we didn't get any errors. What does that tell us? It shows that this problem actually isn't that difficult. Right? Even though it looks like there are 6 tasks, if you condense them, there are really just 2 main tasks, right? The initial download and the subsequent replacements. For each replacement, what actually changes is just the key inside it and the variable in the value, just these 2 things. Of course, except for the last task where we added a condition, or you could say a pipeline. So that's basically what it does. After we finished writing this part, next we'll use it. Let's run a command to check it again. At this point, there shouldn't really be any issues, but it's still best to double check. Actually, as long as you are clear about your own setup, if you're pretty skilled at typing and confident, actually, after you finish each task, you don't really need to check. As long as you're confident and certain you didn't make any mistakes, as long as our playbook runs successfully, then your result will definitely be correct. If the playbook basically runs successfully, but you still lose points on the result, there can only be one reason. You made a mistake in your parameters. For example, if you misspelled a word somewhere, the playbook can't detect that. It just can't. In that case, it's really your own issue. So in this case, if you're confident in yourself, you can just move on to the next question right after executing this, which saves you some time. Of course, it's best to double check. We can use the cat command to directly check the contents of our file. Let's directly check the file contents and see the result. There are 5, so let's check them all. Okay, they all showed up. Now that they've all appeared, there's a problem here, which is... Everyone take a close look and see where the problem is. First of all, node 2, right? These are usually fine because we're using variables, so however many we set above, below it will definitely be node 2 paired with 5, 4 with 4, 3 with 3, 1 with 1, no problem. Next, let's look at the second one, memory. For memory, they're all 9006, which means we set them uniformly, but here there's one that isn't. One of them is set a bit higher, node 1 is set higher, while the others are all 9006. Node 1 is relatively larger. So what about this? Here, you don't need to worry and think, is it wrong because this one is so much bigger? No, it's not. Because our variables are exactly the same. Yes, our variables are exactly the same, so if there were a mistake, they would all be wrong together. As long as it can display normal content like this, then it must be correct. The BIOS version here is actually the same, because when we set up the virtual machines, the BIOS is definitely identical, so there won't be any difference there. Next, the disk size. Let's take a look at VDA10, VDB1, 11, 11, 11, 20, none. This is exactly the point of our final check, because there really is one that doesn't have a VDB. And as for the other VDBs, honestly, they look like they're just there to make up the numbers, right? They're only 1 GB, but for our Note 1, it has a 20 GB VDA and no VDB. So this is actually the significance of the check we just talked about. Without that check, we would run into problems with this question. There would be issues again. Because if we didn't have that check, the last part of this question would throw an error. It would definitely cause an error here. This is one of ours. Question 13. Generating an opinion report is a relatively long question, but overall, as long as you remember the name of this variable, that's pretty much all you need. It's not particularly difficult, not especially hard. Just pay attention to the end, pay attention to the final result. Just make sure that every row has a result. That's all that matters. What the result actually is isn't that important, really. As long as you make sure that every row has a result, it means your variable is definitely working. If you notice that, say all 5 items in a row are incorrect, then you must have written your variable wrong, definitely made a mistake. So the final result here should look like this. If there's a node, for example, that doesn't have ADB, that's normal. The other nodes all have VDB. Also, one of them has more memory and the BIOS is exactly the same across all of them. And then, as for the theme name, just make sure it matches up. The theme name is something that can't possibly be wrong. For the 4 items below, just check which one has an issue. So, if there's an issue with one of them as a whole, then you need to check what's going on. Specifically, check how you've written your variables. If it's just one that has a problem, it's actually not a big deal. For example, if something like non has an issue, it just means it's missing, while the others are normal. Or for example, with memory size, if all the others are 9600 and one is larger, then it's just larger, and that's fine. Maybe it really is just that big, it's just that big. If you want to confirm this, it's actually very simple. You can use a command, right? Just enter the command and use the free command to check the memory size directly. It will definitely show you the actual size. If it's not this, then it's definitely that size. So this is one way to write the answer for question 13, generating a hardware report. If you need the complete structure, feel free to leave a comment below, and you can get the most reliable question bank at the best price. That's all for today. Goodbye, everyone.